in the last lecture we started looking at SQL. So, SQL is going to be a very important component for you. So, so we are going to touch upon the fundamental ideas and some of the fundamental ideas behind SQL, and in the last lecture we looked at how a relation scheme can be defined using constructs that are available in SQL. So, in this lecture we will focus on the one of the most important aspects of SQL, which is querying, querying for information. Now, with this introduction of this, you are now looking at the third way of expressing relational queries. We have started, we looked at relational algebra as one way of expressing queries, then tuple relational calculus. Now, we are going to see SQL, and you can see that the influence of tuple relational calculus exists on SQL. Both tuple relational calculus and the query expression in SQL are thought of as the declarative ways of specifying queries, whereas the relational algebra way of specifying queries is more procedural. Okay. So, with that little introduction, let us get started with looking at what is how we can express queries in SQL. So, the basic query syntax is probably familiar to you by now, because you some of you would have seen this clausal structure of queries in SQL earlier. So, it has a select clause, a from clause, a where clause, and a few other clauses we will see later. So, this is the basic query syntax. So, select keyword followed by a bunch of attribute names. For the moment we will assume that no attribute name appears in more than one relational scheme. Okay. All the relational schemes that we are talking about or in the database have distinct attribute names. No attribute name appears in more than one relation. We will just make a simplifying assumption. We will later relax that assumption. It is not an important assumption. We will relax it. For the moment, we will make such an assumption. So, here a bunch of attributes, a set of attributes from these relations R1 through Rp that are required in the output. Okay. And then the from clause is where we specify R1 through Rp, the set of tables that contain the relevant tuples to answer the query. Okay. And then the most important thing is the where condition. So, the where condition theta is a Boolean predicate, that specifies as to when a combined tuple of all these R1 through Rp, okay, a combined tuple, we will see exactly how the combination works out. A combined tuple or R1 through Rp contributes to the output. So, if it satisfies this predicate, then it contributes to the output. So, what is the condition? A Boolean predicate that has to be satisfied by the combined tuple of R1 through Rp, so that it can contribute to the output. Now, you can see that this, because of this assumption that we made, that all the no two relations have any common attribute name. Okay, attribute name. When you talk about a combined tuple, you can think of a tuple from R1 and followed by concatenated by values from a tuple from R2, concatenated by a tuple from R3, so etc. You can that is what is combined tuple is, and there is no issue in combining them, because all these relations have disjoint attribute names. Okay. So, such a combination we are looking at, and then it satisfies the condition to be so what is the condition it should satisfy, we specify here. And now under this assumption that each attribute appears exactly once in the table, this entire query is actually equivalent to the following relational algebra expression. So, you can imagine that we have R1 cross R2 cross RP, a big cross product of all relations that are mentioned, such that, and then you select tuples from that combination that satisfy this where condition and project A1 through AM. That is the so it is logically equivalent to this relational algebra expression, and with that with this equivalence written down, I think it kind of becomes very clear as to what the select from where query achieves. So, but we will see it in elaboration now, how exactly what is the interpretation, what is the meaning of this basic query block. So, the cross product M of the tables in the from clause would be considered. All tuples in the cross product in the tables of from clause would be considered, and so in that this let us call this cross product as M. So, tuples in this M that satisfy the condition theta are selected, okay, and then from these selected tuples we choose the attributes A1 through AM. We pick up the values of the attributes A1 through AM and mention them, so and in some sense project them to generate the output, So, the output will have as many rows as there are combined tuples that satisfy the condition theta, okay, and the schema would be schema of the output is essentially decided by the attributes mentioned in the select clause of SQL, these projected attributes. So, in some sense this is a conceptual description, this is how we can think of it as being produced, the output being produced. Of course, in practice it is very inefficient to construct the cross product of all the tables that are mentioned in the from clause. So, you will not actually do it that way, but we will find some efficient ways of considering the combinations without actually producing those combinations. Okay. So, that we will see when we come to the stage of query evaluation and things like that. Now, one of course, it will be very clear that the word select in SQL should not be confused with the select operator of relational algebra. It is exactly I mean it is serving a completely different purpose here. In fact, it serves more the purpose of a projection actually. So, that is the meaning of a basic query block. So, you can observe the similarities between this and what we had done in the tuple relational calculus. In the tuple relational calculus situation also, we had considered all possible tuple assignments to the free variables in the tuple that expression, right. And then in that combination, if some of the combinations have satisfied the condition that is there on the right hand side of the vertical bar, then that combination produce the output, and what is the output? Output is indicated by the attributes that are present on the left hand side of the vertical bar, right. So, in a very similar to what we have been doing in tuple relational calculus, we we can imagine this SQL queries being executed. Okay. Now, let us start looking at various other issues. First of all, let us see what is the result. So, the result of any SQL query is a table with select clause attributes as the column names, right, select clause attributes as the column names, and duplicate rows may be present. Duplicate rows may be present in the result of the SQL query. This in some sense differs from the definition of a relation, because in the relation we never allowed duplicate rows to be present, because we defined relations as sets of tuples earlier. This issue of having duplicate rows is important, and first thing is, in case you do not want duplicate rows, SQL gives you a way of specifying that. Okay. So, duplicate rows can actually be eliminated from the output by specifying what is called a keyword called distinct in the select clause. So, if you include the keyword select keyword distinct in the select clause, select distinct name, etc., etc., if you write like that, then duplicates would be removed. Now, there is a reason for keeping the duplicates by default in the result. Mainly you will require duplicate rows, duplicate tuples to be present, especially when you are applying some aggregate functions over the result of these generated results. Okay, over this computed set of tuples, if you want to apply some aggregation function, like for example computing the sum of all the salary values or average of all the age values or things like that, if you want to do some computation, then you should not be doing it on distinct values in the output. You should consider all the values that are present in the instance and then do that. So, so these are essential for computing aggregate functions, and so the default strategy that is adopted by SQL is to give you the duplicate rows. So, in that sense, the tables that SQL produces as our results or intermediate results are not really relations, and that is why we sometimes reserve the word table when we are talking about results of SQL rather than relation. And removing duplicates is also a little bit of a costly operation, because in order to remove duplicate tuples, you can imagine that you have to sort those tuples and then find out where the duplicates are and then remove one copy of them, right. So, it costs some effort. So, the idea is to put that additional effort only when it is necessary and is requested by the end user. Okay. So, that is the output SQL query result. So, now we will start looking at lots of examples and then to illustrate various points about. So, this schema is the same schema as we have been using. So, please keep it handy for you, so that we can start looking at looking at various features of SQL through examples actually. SQL querying portion. Okay. So, let us look at probably this is the same kind of query that we started off with when we were looking at relational algebra, tuple relational calculus. Get the roll number name of all girl students in the department number 5. This involves a single table. All that you need is student. In that student, the attributes, the gender attribute and the department number attribute have to be restricted, and then you can get hold of the roll numbers. So, the way you write it is essentially select roll number name, because that is what is required, ask for. Where does the information come from? It obviously comes from the student table. Now comes this where clause. So, the tuples should satisfy this condition in order to produce output, in order to be used for producing output. So, what is the condition? It should be the gender should be F, because we are looking for women students, and student should be in the depart number 5. So, it is very simple. This is also very simple. So, you can this information also comes from one relation, which is the professor relation. So, we are putting condition on such that the professor is CS department and has joined after. So, we have a join date, join year as an attribute. So, we can use that. So, essentially attribute names and comparison operators with appropriate constants or other attribute names. That is how the basic conditions are to be formulated in these predicate. I said there is a Boolean predicate, right. So, the Boolean predicate is essentially constructed as we did it in tuple relational calculus, but little bit a few restrictions are there, in the sense that we cannot use universal quantification. So, as we see more and more examples, you will realize as to what are the various kind of constructs that are allowed in the Boolean predicate. Okay, so this is easy. Select employee ID, name, phone, that is what is asked for, from professor where department number equals 3 and start year is joined after 1999. Okay. Now, here is another query where a lot of points need to be illustrated. So, we have put lots of boxes around. So, let us read the query. Let roll number, name of students in the CSE department, department number 3, along with their advisor's name and phone number for some reason. Okay. We want to get this information. So, where is this information? Student information is there in the student, and then professor information, because we want advisors are professors. So, we want name of the professors and phone numbers. So, now you will see that the student relation, now here we are relaxing the assumption that we made earlier, that the relations do not have common attributes, right. We will henceforth assume that they may have common attributes, and we will handle them, and the way we handle them is actually by using our familiar dot notation. Okay. So, in order to use the dot notation, we need something before the dot. What is that? Is we introduce what is called in the from clause. It is possible for us to not only just mention the relation name, but we can give an alias for that, a name for that. So, in case you are using student say 2 times for some reason, student as S1 and student as S2, because you want to do some comparison among students. So, you definitely have to distinguish between the 2 uses of the same relation. Okay. So, that is when you will definitely need table aliases. And if 2 relations share attributes, share the same attribute name, then also in order to disambiguate as to which attribute, whose attribute are you talking about, you will need table aliases. So, these S and F are called table aliases. So, student as F, professor as F, and now we need roll number. Roll number does not need to be S dot roll number, you do not have to mention, because only students have roll numbers. Then S dot name to pick up the name of the student, F dot name to pick up the faculty's name, and we are also doing renaming of attributes here in the select clause itself. It is possible for us to do renaming using the word as and giving a new name here, and then phone as advisor phone, so that in the output it is clear that it is advisor phone, not the student's phone. So, we are doing in the select clause roll number, S dot name, F dot name as advisor name, phone as advisor phone, and then in the from clause we introduce this table aliases. Table aliases are required if the attribute name appears in more than one table. And so when same relation appears twice in the from clause, for example, you want to compare for some reason you want to do comparison of tuples of the same relation, right, in two different roles. For example, when you are trying to compute prerequisites of a course or something like that, then you will need to use the course as a course, playing the course, playing the role of a course and playing the role of a prerequisite, right. So it is appropriate to introduce table aliases for that. Now, what is the appropriate condition here that the combination of student and professor should satisfy? First thing is we want the student to be in CSE department. So, S dot department number equals 3. The other one is this combination of the student and the professor should be such that that professor is the advisor of the student. We do not want random combinations, right. So, that is how do you enforce that? You just simply enforce the same by S dot advisor is F dot employee ID. Okay. Now, notice one thing here, that I am very careful not to use the word join condition here, unless you know. So, you can say that the combination has to satisfy this condition. We do not care whether it is a join condition or a selection condition or whatever condition. It is all part of this, the conditions that it should satisfy, the conjunction. So, conjunction is there. Okay. So, this is where it, you know, in some sense we are not telling that okay, you compute the join of S and F with this join condition and then do something, etc., right, as we used to do in relational algebra. But instead what we are doing here is that consider the combination of the students and professor tuples and then ensure that this condition is satisfied by the combination and then use it for generating the output. Okay. So, that is the essential difference between procedural way of expressing queries and the declarative way of expressing queries. Okay. So, I suppose all these points are clear about from this slide as to what we are doing here. We talked about renaming attributes using the as keyword, and the same as keyword is also used for introducing table names or table aliases, alternate names for the same tables, and then the conditions. Okay. So, let us go ahead and look at another query. This is simple. Get the names and employee IDs of 4 members of professors in CRP who joined before 1995. I think similar, only thing was earlier we said we gave the department number for the CSE, now we are saying just CSE department is there. So, the information is available in professor as well as department tables. Why do you need department table? That is because name of the department does not exist in professor table, and we have to act as though we do not know the number of CSE department, right. So, we do not know this number department ID of CSE department, we have to put it as condition here. So, here professor as F, department as D. The combination of professor and department is meaningful if the department number of the professor is same as the department ID of the department tuple. Then we are considering the appropriate combination of professor and department, and then we are putting conditions saying that the department should be computer science department and the professor must have started his surveys before 1995. Is that clear? This. Now, you may say that probably we do not need the table aliases here, because I think the can you please check whether the department and professor have any common attributes? Phone is there common? Name and phone are common. Okay, okay. So you do need. Okay, so now a somewhat unique feature of SQL is that it allows you to kind of introduce subqueries. As part of one query, you can start using a to express a complex kind of a condition. You may sometimes want to kind of break it down and specify the one part of the condition by another SQL query, and then somehow make use of the results of that SQL query in the outer SQL query, outer query block. So, while dealing with certain kind of complex queries, it is sometimes beneficial to specify part of the computation as a separate query and make use of its results to formulate the main query. So, we call such queries as nested or using subqueries. They use subqueries. So, one of the main advantages of subqueries is that it kind of makes the main query easy to understand and sometimes easy to formulate. And sometimes it also can make it efficient to run the main query, because it may be the case that the subquery result can be computed once and then can be kind of used many times while you are running the outer query, though it may not be the case for all subqueries, but these are the reasons why we use subqueries. So, let us see how subqueries can be introduced. Okay, get the roll number names of students who have a lady professor as their advisor. Now, you could imagine a query, an independent kind of a query, who figures out who was lady professors first. This is going to be a little small set, and then imagine that you are getting the roll number names of students whose advisor happens to be in this set of small set of lady professors. Okay. So, one can structure the computation or specification of the query. We do not say computation, because we will only specify the query, right. So, how we can imagine this structuring the specification in such a way that we can imagine that there is a small independent query that can that will produce employee IDs of lady professors, and then we can run a query. The main query, we will only examine students and then check whether their advisors are in the result of the subquery. Okay. So, now actually this brings in a crucial point into consideration, that we need some operators that kind of connect these two queries. We need operators in some sense to connect these queries. So, we use some kind of set kind of operators for doing that. So, let me start illustrating that. So, here is how we could do that using the subquery feature. So, this is the subquery, and we are using the in operator to make use of the subquery results. So, what is the subquery doing? select employee ID from professor where sex equals F. So, you are getting hold of all lady professor's employee ID. Now, what is this table? This table is a single column table with employee ID as a temporary table with single column with employee ID. Now, so in the outer query we are saying get the roll number name from student S where S dot advisor in this set. Those of you who are a little keen eyes will observe that there is a type mismatch here, subtle type mismatch is there, right. S dot advisor as far as we are concerned is actually a single value, whereas here this produces tuples, this produces tuples. Okay. So, let us be conscious of that type mismatch. SQL allows you to kind of be a little bit type liberal. Okay, it says okay fine, we will ignore that type mismatch. The value here is S dot advisor. S dot advisor is a employee ID. So, it is a atomic value, and that atomic value now we are checking whether it is in this set. So, this set is actually set of tuples, each tuple containing one value. Okay. So, technically speaking, very theoretically speaking, the value will not match this because there is a type mismatch. There is a single value there, here is a tuple of single value here, right. So, let us ignore that. So, let us imagine typecasting this as a tuple, S dot advisor, we will convert that into a tuple so that it can now check whether that tuple exists in this set of tuples. So, this in is one of the operators we can use to connect up the subquery results with the main query. So, how does the main query, how does the whole overall query work? Again student tuples will be considered because that is the only there in the from clause, only relation in the from clause, and for each student tuple we are checking whether this particular condition is satisfied, and that's checking the satisfaction or otherwise of this condition involves computing another set of tuples. So, in this case you can see that this set of tuples can be computed once and then reused several times. Will this always be the case? Can this always be the case? Is an interesting question. So, the answer is, of course, the very fact that I am asking such a question, the answer is no, right. So, it depends actually whether when it will be can be computed independently and when it may not be computed independently, there is something else that is probably involved. So, you can imagine that in case this particular thing, so there are it actually the idea of a subquery raises several issues. Can we make use of these table aliases introduced in the main query here? That is a question, right. Should this this has a from clause, but are these the relations that are being considered in the outer from clause, are they accessible here? That is an important question. Indeed, they are actually accessible. So, you could use of, in case it is really needed, you can also use S here. Okay. We will see how exactly such a query can be formulated, but right now first of all let us assume let us settle this issue of how to make use of the result of a subquery in the main query. Okay. Sorry, something else happened. Okay. So, in is there, in a similar way not in also is there. So, in order to so let me go to the detail about what are the kind of operators that are available to do this. So, this they are essentially like set comparison operators, because you have one set of tuples and how it will be compared. So, to deal with the subquery result, SQL gives you several operators. So, the combination of these comparison operators with the keyword any and all can be used as set comparison operators in SQL. Okay. So, let us look at this query. Get the employee ID name of senior most professors. This is the query that you had tried in the quiz, right. Similar query was there for you in the quiz. Now, we can see that with the provision, with the this operators being present, you can actually express this query very easily. So, who is the senior most professor? Whose start year is less than the start year of everybody else, that is it, right. So, now less than is there, less than all, the combination of less than and all can be used. So, professors from professor P, P dot start year is less than equal to all, select distinct start years from professors. So, this professor is different from that professor. So, this is another instance of the professor. So, this subquery, what it is doing is simply taking all the start years of all professors and generating a list of start years, a set of start years actually. Because now, what is this doing? It is just checking that for an individual professor, the start year is less than or equal to all the values here. So, if the start year of a particular professor is less than everybody else's start year, then he is senior most, right. So, this is the set comparison operator that we are talking about. So, in general, what are all the various comparison operators there and what is the meaning of them? This is the general comparison operators. V some value, op operator, op is one of these 6 comparison operators, and S. Any and all is possible. So, let us start with any. V op any S is true if for some member x of S, for some tuple V op x is true, because it is any S, and false if for no member of x, no member x of S, V op is true, where S is a obviously subquery of appropriate type. It, of course, if the subquery produces a wider tuple, then it is an issue, right. Right now, we are assuming that the subtuple produces values, or tuples with single value in each of them. V of all S is true if for every member x of S, every tuple x of S, V of x is true, one of these operators. False if for some member V of x is not true. So, that is the general meaning of these set comparison operators. And you can see actually what we have in couple of slides back, we have used in, but that in is actually equivalent to is a short form for equal to any. So, instead of writing equal to any, we will write in. And what do you think is not in equivalent to? Not equal to not in is equivalent to not equal to something, right, not equal to any or not equal to all. There are only two combinations, any or all. Nobody wants to say anything. Wake up that guy. How are you doing? Is my voice so? Okay, let us see, not equal to any will serve the purpose of not in, not equal to any, not equal to any. So, it will be true if some members of x v of v not equal to is true. So, if it is not equal to one of them, even if it is equal to something else, it will pass, right, it is a dangerous thing. Whereas, we do not, the meaning we are expecting from not in is that it is not there in that particular set. So, be careful. So, not equal to any will not serve this purpose. So, not equal to all is the one that serves the purpose. Okay. So, normally in most cases we use that v is a single attribute, but while using this in or not in, it can in fact be a tuple of attributes also. Obviously, if it is a tuple, then tuple equivalences can be carried out, the tuple is equivalent to the other tuple or not, we can figure it out. There is no, of course, we can't apply other operators for tuples like greater than, less than and all that, it does not make sense, though you can technically probably define that, it does not make sense to do that. So, we while using in and not in, it is possible that the outer query is actually generating a small tuple, and then it is asking whether that tuple is present in the results generated by the subquery. Okay. So, okay, so to summarize, what we have done is to kind of look at the basic structure of SQL queries, which has this clausal kind of structure, select from where, and where condition is the most important thing. So, the condition is a Boolean predicate that has to be satisfied by the combination of tuples that are of relations mentioned or tables mentioned in the from clause, and those combinations will be used to produce the output. And we are now also looking at whether subqueries can be used and things like that. Okay, so we will stop here today.